Hello everybody, my name is April King and I'm the head of website security here at Mozilla. Now one of the things I do a lot with my job is help people out with a piece of technology called Content Security Policy, or CSP. And the idea behind CSP is that if you operate a website, you generate a list of all of the resources that your site uses, and you put this into your Content Security Policy. And it tells the browser, these particular sets of resources that I have listed, might be images or JavaScript files or even things like frame sources or cross-site request or destinations. These things that in this whitelist are all okay. But if you see, for example, inline JavaScript, that's not okay. And this is great because it helps stop a class of attack called cross-site scripting. And what cross-site scripting is where an attacker manages to inject a piece of script into your own personal web page that you have. And when a user is visiting that web page, they see that particular, they come across a particular piece of code, and that code executes. And that might phish them. It might insert advertising. It might try to steal their keystrokes or whatever. It can do a lot of stuff. And CSP says to a browser, if you see this particular, these are the only things that are okay. If you see anything else, just block it. Don't execute it. Don't load it. And that just stops cross-site scripting attacks cold. But the problem with CSP is that it can be very difficult to generate an actual CSP policy. I've been doing this for years, and people come to me all the time being like, April, I have a brand new website. Can you help me generate a policy for my website? And even with a brand new website, maybe even one that's not even doing that much stuff, it can take a long time to generate a CSP. A simple website might take me an hour, but a complex website might take many, many days. It's hard to just get started, and this stops a lot of people who develop their own websites from implementing CSP. The actual amount of work required to do it is just far too high, and browsers have not done a very good job of providing tools to make this easy to do. So today I'm here to talk about a new web extension that I have written and will be releasing to the world called Laboratory. And the idea behind Laboratory, or laboratory, I suppose. Laboratory? Probably laboratory. The idea behind laboratory is that you tell it to monitor a website, and it records every request and every resource that site loads. And then once it's all done, you can say, hey, generate a content security policy for me based on what you have seen. So let's talk a little bit about laboratory and how it works. All right, so let's get started here. So I've loaded up a Firefox here, Firefox Dev Edition. This is version 53, which is, I believe, the minimum version required to do what this particular extension is doing. So if you're on the stable version of Firefox, you might have to wait for a little bit. But if you use Dev Edition, you can use it right now. And let's pop open our little Erlenmeyer flask or whatever it is. And boom. So here's what we got. We have a thing here that says record this site, and you have below here the generated CSP based on what it has seen. And down below, we have a whole bunch of different configuration settings that you can set that change basically how your CSP is created, how it's crafted. So right now we have my own personal website, Poke-in-the-IO, which already uses CSP, but it took me a long time to do it. So let's see how quickly I can generate a CSP without having to, sit and stare at the browser console and do trial and error again and again and again. So we're going to click on the little flask icon here and choose to record this site. So now the extension should be recording every resource that it loads. So we'll just actually refresh this page. And let's see if it has done anything, if it's seen anything. Oh, all right. Well, it's seen it's seen images from itself, it's seen scripts from itself, styles from itself, and it's loaded a style sheet from fonts.googleapis.com. That was pretty easy. All I did was refresh the page. Now, I personally know that I have other things on here. So let's go to, publications here. And I know that, for example, I have a video here that I recorded. And this one actually loads a it loads a YouTube video up. So we'll start playing this and see if that managed to change what is in here. Hey, there it is, frame source, https youtube.com, and that's because here I have embedded a video from youtube.com. Well, this actually here, what you see here, this CSP, this is actually the CSP that I use for my own personal website. It's actually perfect. It's actually right on. So now we can go and we can play around with the configuration options. So we have here, we have it set so that, image source is origin, media source is origin, script source, object source is path, and so on and so forth. And what this does is it changes what appears in here. So for something like script source, I have it set to self if it's the same origin, otherwise path. But we can set it to the full complete path of the entire script. And now you can see that I have a script source of this here, this one exact path to something, this exact path to jQuery, and so on and so forth. And the idea here is that it's set to basically reasonable defaults, but if you load a script from your own origin, in this case poke in the IO, you could just say self, and that's fine. But if you load it from anywhere else, you want to be very, very specific about the particular script that was loaded. I can change style source. Right now I have style set to self if the same origin, otherwise directory. So you can see here it's just loaded something off the top level directory of fonts.googleapis.com, but we can set it to the full path. And now we'll see here that we have the full path of the scripts on my own, or the style sheets on my own website. Oh, I see. That's right. Google APIs actually just generates a style sheet based off the root directory. But you can dial any of these down as specifically as possible. You can do it by directory. So this is just the directory that contains the image file or the script. You can do origin, which is just the top level domain. So it might be poke in the IO, it might be youtube.com, it might be googleapis.com. We have path, which is the full complete path to a resource. And then we have, these different options that are basically directory or path, but if it's on the same origin, in this case poke in the IO, it's just self. So let's try out another website. Let's look at, say, google.com. And we'll tell it here to start recording google.com. And do a refresh. And let's see if we have a CSP. Hey, we do. So we can see here that Google is connecting to itself. It loads images from itself and SSL, like gstatic.com. It loads scripts from all of these resources, all along exact, very specific paths to things. But we could just set it to be just the origin, or just self here. So we can see, now we've got script source, self, and script source, apis.google.com and gstatic.com. So yeah, this is just the basic idea. It has just generated a CSP for me, and it's that easy. As long as you're recording google.com, you can search for yourself, and you can browse around, and you can navigate, and you can do anything you want. And it's recording every single one of these requests that it has seen to generate a CSP. You can see that we've added a couple new image sources here. We've added Geo3, and we've added Google user content. And this is great. So now instead of, trying to guess or look around and try to look at the console log of your browser and see, oh, this was blocked and this was blocked and this was blocked, or looking at the network tab and seeing all the resources and just trying to make it work, this just does it all for you. It's just that easy. And when you're all done, when you think you're happy with it, you can just copy it to your clipboard. And there it is. You just paste it into your web service configuration, and you're completely done. So that's the basic idea behind how the extension works. And next, I'll talk about the very nitty-gritty details of the innards of the extension. So if you are a web extension developer, or if you find this stuff very interesting, stick around, and we'll chat about it next. All right, so let's talk about the technical details. When I first made the extension, I thought, well, this will be very easy. All I will have to do is set a listener for onResponse started. And what that means is that The web browser has made an HTTP request or an HTTPS request outward, and it has received the headers from the file or whatever from the resource that it has requested. And I can look at those headers and the request, and it'll tell me things like, hey, it's a style sheet, and this is its URL. And that's all I would need to do. I'll just record that it was a style sheet, and this is the URL. I'll record that it was a script, and this is the URL. And that worked actually pretty well. You know, obviously there's some weird things, like you could beacon requests and all sorts of random stuff showing up in there, but I thought, well, this is great. Problem solved. This is going to be very simple. I just have to have one listener, and that's all there is to it. But I ran into a problem, and that was that the onResponse started request, or the onResponse restarted listener only will actually send me responses that it actually gets. And in order to have a response, the web browser has to make a request, which means that it was only seeing resources that were requested over HTTP or HTTPS. But when you have something like CSP, you also want to list things like, was there unsafe inline style sheets? Like, did somebody set a style attribute on a tag? Was there unsafe inline script? Did somebody load an image from a data URI? You know, which is very common. You know, you see that a lot with style sheets, and those are blocked or not blocked by CSP, but I couldn't see those with my listener because they weren't actually making a network request. So I thought, well, one thing I could do then is I could inject a content script into each page, and once the page finished loading, I could just traverse the DOM, and I could look for every possible any possible location that a piece of script or style or whatever was being loaded for. So I could look for, you know, I could look for images with hrefs that are data. I could look for script tags that, you know, don't have an SRC tag, and so on and so forth. And I could use those to build up a CSP from that. But that has a couple problems. One is that it's very slow. You know, having to traverse the entire DOM takes forever. And it also, it's just hard to do because there are so many different ways to load a resource in HTML and CSS. You have hrefs and SRCs, and there's so many different ways. It's actually very complicated to find all the ways that you can load a resource. So I was like, well, this isn't working. I'm only getting, it's still great. Like, I was able to see all of the external resources, all of the networked resources that are being loaded, but I'm still missing a lot. Can I do better? So then I thought, well, how about this? What if I, instead of listening to all the responses, what if when you request a page, I injected a fake CSP header? So I stripped out the ones that were there, and then I would add a CSP report only header that says default source none. And what that tells the browser is, don't actually block anything, but generate a CSP report as if you had. And this actually caught everything, right? I mean, well, what would happen is that the browser log would get spammed. Like, you would see hundreds of CSP reports, like this data URI was blocked, this style sheet was blocked, this script was blocked. And so I thought, okay, well that's working. Now I can change that header so that instead of just blocking everything, it also sends a CSP report to a fake URL. In this case, you know, if I'm going to poke in the IO here, you will send a fake CSP. You'll send a CSP report to, you know, /laboratory fake CSP report or whatever it was. And then I set another listener on that. So I set an on before request listener for those CSP URLs and say ingest the CSP report. So I take the body of the CSP report, I pull out the URI of the resource that was blocked, the directive that blocked it, so it would be like style source blocked it, or script source blocked it, or whatever. And then I could use that to build up a CSP. And then once I've, you know, ingested the CSP report, I just tell the browser to cancel the request. Don't actually send the fake CSP report. And that actually worked perfectly because that does see inline scripts, that does see data URIs, that sees everything. And you'll actually see that here if you bring up laboratory and click record this site, and then we go into the browser console. Let's clear this out here. Actually, we can just filter for, so content security. All right, and then we just refresh the page. All right, so you'll see here that it just generated a whole bunch of CSP reports, and every one of these was ingested by Laboratory, and it used that, you know, it said script source here, and it has the resource. And now it knows that you need to have this resource inside script source. It says image source was none here. That was the directive it injected. I have the actual resource here. This is the image that was blocked. And now I know another resource that needs to be listed in the CSP. And this is how it does it. This should catch pretty much everything. It catches inline scripts, inline styles, it catches data tags, it catches HTML, hrefs, it catches everything. Everything that CSP would block, it lists in the CSP header so that it would not be blocked. So that's how it works. It has an on headers received listener that injects, you know, CSP report only, style source none, script source none, image source none, frame source none, etc., etc., etc. That causes fake CSP reports to be sent to a URL that doesn't exist, but I have an on before request listener that listens for that particular URL pattern, ingests the CSP report, and then just drops that request. And that's it. That's how it works. If you have any questions about the inner functionings of Laboratory, feel free to comment on this video or send me an email at april@mozilla.com, or you can look in the GitHub repo and open up an issue under Madumari is my username, and then the repo is Laboratory. So I hope you all enjoy this. I hope this is very helpful in your career, in the things that you're doing. I hope this helps you implement CSP in a way that's just so much faster than the old method that you had to do before. So thanks a lot, and enjoy Laboratory.